Good afternoon and welcome to the Eastern Tallgrass Prairie and Big Rivers LCC Spring Webinar Series. My name is Abby Donnelly. I'm on staff here at the LCC. Both our coordinator, Kelly Myers, and our science coordinator, Gwen White, are out on meetings this week. This webinar is the 7th week of our series presenting projects of our partners and focal areas to show just what our LC is up to these days. Today, we have Mark Herse from Kansas State University. He's going to be presenting on patterns and drivers of habitat selection by Henslows Sparrows. Welcome, Mark. You can get started.
All right. Thanks for the introduction, Abby, and thank you all for logging in today to hear me talk about the first chapter of my master's thesis here at K-State. Real quickly, I'd also just like to point out that a lot of this work was carried out with the help of my advisor, Alice Boyle, who's the principal investigator on the project, my committee member, Brett Sandercock, and then my collaborators, Mike Esty and Pamela Moore with the Fish and Wildlife Service. So animals select habitats by making a series of choices, and these choices are based on trade-offs between factors such as availability of food, opportunities to reproduce, and access to shelter. And the decisions are really important because they influence an individual's fitness as well as the population's persistence. Now, most habitat studies tend to focus on how animals make fine-scale habitat choices. So, for example, for a grassland bird, this might mean looking at where they're establishing a territory, and then within that territory, what kinds of microhabitats they're using to build a nest, to rear offspring, and to forage and things like that. But all the while overlooking choices the animals have already made at broader spatial scales while they're assessing landscapes and trying to decide where to settle. So I'm really interested in understanding how species perceive and respond to this broader scale landscape heterogeneity. Right now there's an urgent need to understand how these factors influence habitat selection processes in North America's grasslands because they're changing so rapidly. As most of you probably know, the tallgrass prairie represents the most altered ecosystem in North America. About 2% of its historical extent remains. And in the areas that are remaining, we see either excessive burning, grazing, and haying, which further degrades prairies, or on the opposite end of the spectrum, we see complete suppression of ecological disturbance, and that allows woody vegetation to encroach onto prairies. So the grasslands are getting hit pretty hard, and as a result, we've seen grassland birds decline more rapidly than any other guild of birds in North America. Now, among the most at-risk species of grassland birds is the Henslows Sparrow. They've experienced long-term range-wide declines attributed to habitat loss and fragmentation. And as a result, they're currently recognized as the species of highest conservation priority in the U.S. in eastern and midwestern grasslands. They're migratory, they're very rare, and they're notoriously elusive. For the past century, they've been described as spatially unpredictable, appearing and disappearing from prairies within and between breeding seasons. But most studies of Henslow sparrows have been focused on fine-scale habitat choices, and there's still not much known about how they respond to broader-scale landscape heterogeneity. Now, about 80% of their remaining breeding habitat is in the Flint Hills of eastern Kansas, but there's really not much work that's been done in this region. The Flint Hills Legacy Conservation Area was established in 2010 by the Fish and Wildlife Service to protect more than 1 million acres of the 6 million acre region, and one of their top priorities is to protect habitats for Henslow sparrows. So I'm asking here what landscape factors drive habitat selection by Henslow sparrows, and there's 3 hypotheses that I'd like to focus on here to explain this or answer this question. One is what I call the grassland availability hypothesis. Now, if sparrows only require enough habitat to establish a half-a-hectare territory, then I predicted that the probability of occurrence should increase proportional to the percent of grassland cover within landscape greater than this half-hectare size of a territory. Alternatively, the landscape context could influence their habitat choices. So these birds evolved in large prairies where they could have developed an innate preference for interior habitats away from grassland edges. Now, they also tend to congregate in groups, so they may require larger grasslands than we typically associate with individual territories. So if this is the case, I predicted that the probability of occurrence would increase abruptly in extensive grasslands, but be low with intermediate or small amounts of grassland cover. And third, rangeland disturbance. So we know that Henslow sparrows require tall, dense vegetation that provide concealment for nesting and foraging. So if rangeland disturbances are driving their habitat choices, then I predicted that these birds shouldn't be using areas that have been burned earlier the same year and would likely leave sites that have been hayed in the summer. So to get at this question, we conducted surveys from thousands of points located along survey transects in eastern Kansas using a modified version of the breeding bird survey protocol. We visited each of these transects 3 times per breeding season during 2015 and 2016. And at each site, or at each point, we conducted a 6-minute survey recording all the birds that we saw or heard. Now, there's 7 measures of landscape heterogeneity that I want to focus on here. So non-spatial measures of landscape composition I was interested in looking at are 1% conservation reserve program area. So these are grasslands that have been restored through conservation easement programs. And are not disturbed very often. They typically have tall, dense vegetation. And I was also interested in looking at how sparrows respond to non-CRP grasslands. So this typically is going to be working rangelands, grazed pastures, and such. And then I also wanted to look at total grassland percent, which is a combination of CRP and non-CRP, just in case sparrows aren't actually distinguishing between these 2 different grassland types. And then last, percent woody cover in landscapes. I also looked at number of grassland patches within landscapes to represent an index of fragmentation, and this helps account for spatial heterogeneity of grasslands. And then also categorize just the local area around each point within our detection radius, local disturbances, so whether or not sites were burned or unburned, or hayed or unhayed. Now, for these measures of landscape composition and fragmentation, we quantified these within 3 spatial scales centered around each point. The finest scale is the area within a 400-meter radius, and this encompasses our maximum detection radius of birds. And then we extended it all the way out to 1,600-meter radius. So we know that these birds have been documented moving more than 1 kilometer between breeding temps within the same season over in Missouri. So we let these represent potential search areas that Henslow sparrows are assessing when they're deciding where to establish a new territory. So we use multi-season occupancy models to investigate within-season site occupancy dynamics. I don't want to get too bogged down in this and bore you all, but I do want you to understand how these models work. So basically what we have is each survey at each site during each season is a primary sampling occasion. And then within each primary sampling occasion, we have individual survey minutes, which are secondary sampling periods. So we recorded for each individual minute detections and non-detections for each individual bird that we encountered. And then we assume that birds are not moving in or out of sight during a given survey. But in between surveys, these are open, and birds can be moving in or out of sight. And so in the closed portion of the model, we get estimates of probability of detection, so probability of detecting an individual sparrow given that it's present during a survey, initial occupancy, which is the probability that a site is occupied during this first survey period, so this is during the early season of a given year, and then the open part of the model provides estimates of colonization. So this is the probability that a previously unoccupied site becomes occupied later during the same season, and local extinction, which is the probability a previously occupied site becomes unoccupied later during the same season. We use this approach because we're interested not just in understanding how landscape factors affect probability of sparrow occurrence, but also how habitat associations change within each season and what factors influence probabilities of birds appearing or disappearing later during the season. So we used a suite of models to represent our hypotheses. And then we distinguish between those hypotheses, between those competing models, rather, using information theory, so differences in AIC values and a QQ weight. All right, so all in all, we conducted over 10,000 surveys during the study. We detected Henslow sparrows at 27 sites in 2015 and 75 sites in 2016. So during any given period of either breeding season, sparrows, based on these estimates, inhabited less than 1% of eastern Kansas. We only had 4 sites with detections during both years, and of the 98 unique sites where we ever detected sparrows, 75 of those sites, we only had a detection during a single visit. So we had this really strong pattern of birds appearing and disappearing between seasons and within breeding seasons. Probability of detection for Henslow sparrows varied with year and with survey rounds, although the interaction between these two effects was mostly driven by this low probability of detection during the early season of 2015. But overall, during the course of the study, detectability was imperfect, but it was right around 70%. So not terrible, but not perfect. But after accounting for this observer error in our models, then we can move on and look at habitat association. So I'm going to start by looking at habitat associations from the early season and then move progressively towards the middle and later part of the season. So during the early season, what we found is that sparrows responded to landscape heterogeneity most strongly at that local 400-meter radius scale, and they only selected unburned sites containing more than 50% grassland cover. So we never found them at burned sites during the spring. They responded positively to non-CRP grass and CRP grasslands, but at varying magnitudes. And then they responded negatively to the amount of woody vegetation. So this first plot that I'm going to show you here, this is probability of initial site occupancy as a function of the percent of non-CRP grasslands. So what you can see is that we really don't see this curve increase at all until we have landscapes comprised mostly of grasslands. And even at 100% grasslands, probability of occupancy is still really low at about 2%. But again, increasing abruptly in landscapes comprised entirely of grass. So sparrows responded much more strongly to CRP grasslands, but what was in the surrounding landscape around the CRP grasslands was as important as the CRP grasslands themselves for attracting birds. So this plot here on the left, what we're looking at is site occupancy as a function of CRP, where the non-CRP area is made up mostly of grass. So here we have a small amount of CRP, and here's a plate to show you an example of a landscape taken from GIS where there's a small amount of CRP embedded within a rangeland, and what we see is that occupancy increases all the way up to 10%, which is 5 times higher than we saw on that previous slide. But if we look at a plot now where we have the same amount of CRP embedded in landscapes where there's a small amount of rangeland, we can look here. We have the same amount of CRP in a landscape that's comprised largely of non-grassland area, and occupancy is near 0. So the area around the CRP is critical for attracting sparrows. And now on the far side of this curve, what we can see is that when we have large amounts of CRP, so in this case 75% CRP, we see this probability of occupancy increase all the way up to 50%, which is huge for this species. But I also want to point out that these types of landscapes are really rare. So we only had 5 landscapes at this scale out of more than 2,000 of our landscapes that we were looking at that had more than 50% CRP. So really extensive areas of CRP are rare, but they do attract sparrows. So last, during the early season, sparrows strongly avoided landscapes containing any amount of trees. So you can see in this plot with any amount of woody vegetation, any chance of a site being occupied just drops. So they're not using the sites where there's trees. Now moving on to the middle and later part of the season, interestingly, we found strong evidence that sparrows responded to landscape heterogeneity at a broader 800-meter radius scale during mid and late season. So the relationships with CRP and trees stayed the same even though they're at these broader scales. So I'm not going to show plots for those because it's a lot of the same type of information. But interestingly, we found that now sparrows are responding negatively to the number of patches in grasslands, so negatively to fragmentation. So this plot here on the left that I'm showing you is probability of site colonization, the probability of birds settling in sites during mid and late season as a function of the percentage of non-CRP grasslands. And again, we see the same pattern where there's really very little or no chance of a site being colonized unless we have mostly or entirely grass making up that entire landscape. But now if we look here, this is where the grasslands are consisting of a single large tract of prairie here. But now if we look at the same amount of grassland with increasing number of patches, so here I'm showing 3 and here 5, just to give you an idea, you see that even if we look at the same value of percent grassland habitat, so here, for example, 75%, if you compare on these 3 plots, and the plot on the far right, basically no chance of birds inhabiting any of these sites when they're highly fragmented, even when you have mostly grasslands in that landscape. Also, we found that after mid-June, sparrows began colonizing sites that had been burned earlier in the same year, which is really neat. And now moving on to probability of local extinction. Sparrows tended to disappear from landscapes that were not comprised entirely of grasslands, and they always disappeared from sites after they were hayed. Even after accounting for imperfect detection, we found that on average, a site inhabited by Henslows sparrows had about a 90% chance of becoming uninhabited later during the season. But the chance of birds remaining in a site for the entire season was highest when they're embedded within a landscape comprised entirely of grass at this broader scale, which corresponds with about 200 or more hectares of grass. Now, these strong patterns of apparent within-season movement and shifts in habitat associations could be explained by sparrows searching for suitable dense cover for nesting. So sparrows favored CRP grasslands throughout the breeding season, but elsewhere they may be forced to make the best of a bad situation in spring when tall vegetation is most limited, but then in summer as new vegetation emerges in working rangelands, sparrows may move to those more extensive ungrazed areas. And this would explain and could help explain the increase in the spatial scale response that we saw and also the negative response to fragmentation later in the summer. So coming back to our question, what landscape factors drive Henslow sparrow breeding habitat selection? Hopefully we've shown you that sparrows aren't using all of the grasslands that are available to them, but landscape context and rangeland disturbances are driving their habitat choices. And so a few other things I'd like you to really take away from this are that even in the Flint Hills region, Henslow sparrows are extremely rare, even in this big prairie system, and they're highly mobile within breeding seasons. Grassland area fragmentation and characteristics of the landscape outside of the grasslands or outside of the habitat are all interdependent as drivers of habitat selection. Again, sparrows really strongly favored CRP in those more undisturbed areas, but particularly when they're embedded within rangelands, which suggests that developing relatively small amounts of habitat or of CRP in highly developed agricultural landscapes may be futile for attracting these birds. And last, managing for sheer grassland area won't guarantee occurrence or persistence of the species. Mitigating species declines definitely requires that we protect large swaths of prairie, but we also need to be thinking about how those prairies are managed and the vegetation structure within them. So all of that being said, I still have a lot of work to do, and I think there's a lot that we can learn from these remaining prairies. I'm currently working on analyses on several other priority species, particularly the grasshopper sparrow, upland sandpiper, and greater prairie chicken. I hope to share more results on that in the future, so hope that you'll stay tuned. And I would be more than happy to take any questions. I'd also like to thank my funding sources, and then folks here at K-State, my lab and field assistants, and then some folks with Kansas Department of Wildlife, Parks, and Tourism for accommodating our field crews. And if you have any questions, I'd be more than happy to try to address those.
Okay, well, thank you so much, Mark, for presenting. If anyone has any questions for Mark in the future or for any of our other presenters these past weeks, all of the contact information can be found on our website, easterntallgrasslcc.org. We also have all the recordings for our past webinars up if you missed any. Next week, we have Ray Wright from the University of Missouri discussing new data they've done on the interactions between cover crops and wildlife. That's on Wednesday, 5th of April at 2 p.m. Eastern Time. The announcement that was sent out on Monday has the wrong date, so be sure to put this on your calendars for next week. Thank you all for joining, and we'll see you next week.